Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 3E assignment. First one we're going to take a look at here is a number 1. Which of the following numbers are not written in scientific notation? So this first number has to be between 1 and just less, and has to be less than 10. So that qualifies. Check. And then this has to be written as 10 to some power. Check. So this one, this is... ask which ones are not. This one is written in scientific form. Okay. Number 2, write in scientific notation. Basically, remember, always start from the left and go over until you find the first non-zero, which is this one here, and put a decimal right after it. So this will be 2.59. I'm going to do this instead of writing it on there. I'm going to turn this into 2.59. The decimal was here. I had to move it 2 to the left. So to compensate for that, if I move it 2 to the left, I actually made this number smaller. So I have to get it back to what it was, I'd have to multiply by 10, however many decimal spots I moved. 1, 2 to the left is going to be 10 to the second. If you take 2.59 times 10 to the second, you get 259. Okay. Same idea here. Move the decimal over. We're going to move it over 1, 2, 3, 4 spots. 2.59 times 10 to the... And now since we made this small number, we made it bigger. Oops, 59. Since we made that bigger, we have to make this smaller, so it has to be negative, and it's however many spots we moved over. 1, 2, 3, 4. 10 to the negative fourth. Okay? Okay. Moving on to number 3, write each number in scientific notation. The mass of RMS Titanic was approximately 47,450,000 kilograms. So we would write that, the decimal, going from the left. Here's the first non-zero. Put the decimal right after the first non-zero. So it's going to go right there, right? So 4.745 times 10 to the decimal originally was right there. 1, 2, 3, 4, 5, 6, 7 spots over. And since we took this really big number and we made it small, this has to be positive to make this number back to this big number again. This little number get back to the big number. Okay? So it's always positive if you're taking a big number and making it smaller. And then it's always negative if you're taking a small number, like some 0.000, and you're turning that into a bigger number. Okay. Write as an ordinary number, 4 times 10 to the third. So that's going to be 4 times 1. The 10 to the third basically means 3 zeros. And so that means you're going to move this. Right now the decimal is right here. And we're going to move it over 1, 2, 3 decimal spots. 1, 2, 3. Fill all those little loop-de-doos with zeros. So it's just going to be, let's do this. Let's rewrite it as 4,000. Okay? 8.6 times 10 to the first. Another easy way to look at this is a positive one. Positive means we're going to move the decimal to the right. So this is going to be 86. Okay? All right. Write as an ordinary number, negative 4 times 10 to the negative 3. So right now the decimal is right here. Since it's negative, we're going to move it to the left. 1, 2, 3. Fill those in with, fill those little loops in, those little divots, loops, whatever you want to call them. Fill those in with zeros, so it's 0.004. Okay? 8.6 times 10 to the negative first. It's negative 1, so we move it to the left 1 spot. So it's going to be 0.86. Okay? All right. Number 6, write as a decimal number. It's estimated the population of the world in 2020 will be 7.4 times 10 to the ninth. So we are going to take this 7.4 and we're going to move it over 9. Since it's positive, it's going to be 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where the decimal is. These are all going to get filled in with zeros. So there's a comma there. There's a comma there. 7.7 billion 400 million. people. That's a lot of people. And that's this year. Well, right now it is anyway. Okay. 7, write these calculator displays in scientific notation and as decimal numbers. This is a really good question because I can't tell you how many times I will see people write this answer just like this is what they get on their calculator, and so they'll write that on their test. You need to know that this means 4.5 times 10 to the positive 7th power. That's what that means. Okay, so scientific notation as decimal numbers. So we would take 4.5 and move it, since it's positive 7, we move it 7 to the right. 1, 2, 3, 4, 5, 6, 7. Fill all those in with zeros, and there's a comma there. There's a comma there. 45 million. Okay. This one here, 1.6 times 10 to the negative 6 is how we would write that in scientific notation. And then we take the 1.6 and move it, since it's negative, we move it to the left 6 spots. 1, 2, 3, 4, 5, 6, 7. So 0.00000016. Just like that. Okie dokie. All right, number 8. Use your calculator to evaluate the following, giving your answer in scientific notation. So let's do that. Okay, here's our calculator. So we can just enter it in just like it looks. And actually, this one's probably going to actually automatically put it into scientific for us because it's such a big number. 68, and then 1, 2, 3, 4 zeros. Times 73 million. 1, 2, 3, 4, 5, 6. Did I get all of them? 1, 2, 3, 4, 5, 6. Enter. And look at that. It gives it to us in scientific notation. How handy. Give your answer in scientific notation. So normally we just do 3 significant figures. So 4.96 times 10 to the, I believe it was 13th. Yep. Okay. This one here, I would want to do this. 3.16 times, we can even just do this right like this. So times 10 to the negative 10th equals, did not work, huh? So times 10 to the negative 10th, like so. And then I got to get rid of this. Delete and delete. There we go. So that'll give us that. And then we divide that by 6. I'm going to do this just to make sure that it works right. I'm going to put this in parentheses. Divide by 6 times 10 to the 7th power. I'm going to go over, push my parentheses. And that should give us, look at that, 5.27 times 10 to the 18th. Okay. So depending on your calculator, might already, most of these, since these numbers are so big and so small scientifically, it's going to give you your answer in scientific notation anyway. And it could give it to you in that old form depending on what kind of calculator. That e to the 10th or e to the negative 10th or something like that. Okay, number 9 here. Last year, a peanut farmer produced 6 times 10 to the 4th kilograms of peanuts. If the average weight of the peanuts was 8 times 10 to the negative 4th kilograms, how many peanuts did the farm produce? Okay, so we produced 6 times 10 to the 4th kilogram. If each peanut weighed 8 times 10 to the negative 4th kilogram, we would take that and divide it 8 times 10 to the negative 4th. Okay? Reason why we do that is, like, let's say if each peanut weighed 2 kilograms and we had 1,000 kilograms, to figure out how many total peanuts that would be, you take 1,000 and divide it by 2 and say, oh, that's 500 peanuts, right? Okay, so same idea here. Now, before I showed you doing this on the calculator, another way you could do this is actually treat these as two separate little problems here. So we'd have 6 divided by 8, which is 0.75. And then we'd have 4 minus negative 4 times 10 to the positive 8th, right? Because that's 4 minus negative 4, which is 4 plus 4, which gives us 8. Okay? But that's not quite scientific notation, so we'd have to move the decimal over 1 to the right there, so it would be 7.5. We took a small number and made it bigger, so we have to make this smaller, so we'd have to subtract 1 times 10 to the 7th. Okay? Or, again, you can always do it on the calculator, too. But if you got to make sure you enter it in correctly, otherwise it's going to mess you up. So 6 times 10 to the 4th. I like to, there we go, divide by, let's see if this works. 8 times 10 to the negative 4th. This will be interesting. Aha, see, look. That's why we have to put it in parentheses, because otherwise it's going to do 6 times 10 to the 4th. It's going to divide that answer by 8, and then it's going to multiply that answer by 10 to the negative 4th. So that's not what we want. So what we want to do is take this same info here, and we got to move our cursor back over here, and we can do insert. So second insert, and I'm going to put parentheses in there, and then it should work out. That's why doing it this way is not a bad idea, because I know I'm going to get the right answer. So look at that. There's our 750, well, 1, 2, 3, 75 million, right? So that would, this calculator is going to give us 75 million. So then we'd have to do 7.5 times 10 to the, decimal is here, 1, 2, 3, 4, 5, 6, 7. Either way. I kind of prefer this way. I think that might be a little bit easier. But your call. Okay, last one to look at on this one. The closest distance between Earth and Venus in their orbits is about 3.8 times 10 to the 9th meters. Closest distance between Venus and Mercury in their orbits is 7.7 times 10 to the 9th meters. Spacecraft is sent from Earth to Venus, waits for the opportune time, then travels to Mercury. Okay, so Earth to Venus is this far, and then Venus and Mercury is this far. Okay, find the minimum distance the spacecraft must travel. So it's going to be 3.8 times 10 to the 9th plus 7.7 times 10 to the 9th, right? So we could do that on our handy-dandy calculator. You just want to make sure that we put, I'm going to put both of these in parentheses so that we get this plus this, because that's what we want, just to make sure. Order of operations on the calculator is going to do it for us anyway, but it's just kind of a good habit. 3.8 times 10 to the 9th plus 7.7 times 10 also to the 9th. Ooh, look at that big mess that I made there. Times 10 to the 9th, go over and then close the parentheses, plus, and then we'll do parentheses again, 7.7 times 10 to the 9th, go over, close, push enter, 1.15 times 10 to the 10th is our answer for A here. Okay, and then for part B, discuss the assumptions that you have made in your answer. Well, we just have to assume that we're always going to be on the side of the planet that is closest to the other planet. You know, I mean, it's not going to make a huge difference, but it would make a little bit of a difference. Okay, and it could probably take a long time for these things to happen. But that's really pretty much the big assumptions there. Okay. All right. That's all we have for the 3E assignment. If you have any further questions, please feel free to ask. Thanks.